Okay, so I want you to just watch this. Let's say I have y is equal to 3x squared, and I wanted to find the derivative. So I'm going to do the limit as x goes to 0, and then I would plug in x plus h into my equation, and then subtract f of x, which would be 3x squared all over h. And I could square that and distribute the 3 and collect my terms and then plug in 0 for h, right? We should be able to do that, I hope. Okay, well, let's say I have something like this. Let's say I have y equals 1/4 x to the negative 2 plus 3x to the 8th. Can I plug in x plus h and do the same thing? Yes, but it is going to get, shall we say, ugly. Right? Am I wrong? No. Okay, so what we're going to look at today, there is a shortcut for the derivatives. And so let me show you the shortcut and see if you can figure it out. Physics people, be quiet. Okay, so let's say I have y is equal to 7, then y prime would be 0. And y is equal to 7x. And y prime would be, derivative is the what? It would be 7. So y equals, let's say it's 7x squared. Then my derivative is going to be 14x. And let's say that y is equal to 3x cubed plus 8x squared. Y prime is going to be 9x squared plus 16x. What's my shortcut? You see the pattern? Multiply what by the exponent? You're saying take the exponent, multiply it by the coefficient. Why do we take away 1 degree? Because my helpful hand. Oh, the helpful hand says what? The derivative is always 1 degree less. Okay? So from now on, you can use your shortcut, unless I specifically tell you not to. We're going to look at derivative rules today. There are 4 rules that you need to know. All right, so let's take a look at that. And here we go. So first rule. First rule is this. It's called the constant rule. The derivative of any constant is 0. So if I have y is equal to 5, then y prime would be 0. Why is it 0? Because what's the shape of the graph of any constant? It's going to be horizontal line. And what's the derivative of a horizontal line? It's the slope, which is what? 0. Always? Always. Okay? Has to be. All right. That's the first rule. Second rule is called the power rule. It's the shortcut Okay, so if I'm taking the derivative of x raised to the something, I take the exponent and multiply it by the coefficient, so that n would come out front. And then I'm going to subtract 1 from my exponent. Okay, so y equals 3x squared. Y prime would be 6x. And if y equals, let's say it's something like 4x cubed minus 6x plus 7, y prime would be 12x squared. Okay, I take the exponent, 3, multiply it by the coefficient. 3 times 4 is 12. Decrease the power by 1. Derivative of negative 6x. It's just a linear function, right? If you only have the x there. That's going to be minus 6. And derivative of 7 is 0 because it's a constant. Okay? So far, so good. All right, well, then we have the product rule. This is my good friend number 1. This is my good friend because we hang out a lot together in calculus. I hope it will be your friend as well. First of all, what does product mean? We are multiplying. Okay, so here's my little catchphrase. For the product rule, we say first times derivative of the second plus second times derivative of the first. First times the derivative of the second plus second times the derivative of the first. Okay, so that is Newhouse's notation. Let me give you a little formal notation. Let's say I want the derivative of u times v, where u and v are functions. I want to have the first times the derivative of the second, so v prime plus, that looks like an and, I'm going to fix that, plus the second times the derivative of the first. So let me give you an example. Let's say, let's do it right here. Let's say I have y equals 2x plus 5 times x cubed minus 7. Okay, so this is my first term. This is my second term. Y prime is going to be first term, which is 2x plus 5 times the derivative of the second. So what's the derivative of x cubed minus 7? 3x squared plus second term, which is x cubed minus 7 times the derivative of the first term, which is 2. First times the derivative of the second plus second times the derivative of the first. Could I switch these? Yes. Sure. 3 plus 5 is the same as 5 plus 3, right? Since I'm adding them and since I'm multiplying them, okay? The order here doesn't matter, okay? And unless I tell you, I would leave it unsimplified, just like that. Okay? Question so far? I've got one more rule. This is my good friend number 2. The quotient rule. What do I mean by quotient? I'm dividing. Okay? Put your pencils and or writing utensils down for a second. And repeat after me. Got it? I need my ruler here. It's like I'm a maestro at the orchestra. So repeat after me. Lodi high. Minus high low. Over low square. Lodi high. Minus high low. Over low square. Lodi high minus high low over low square. That was terrible. Please do it together. Again, after me. Lodi high minus high low over low square. Again. Lodi high minus high low over low square. Lodi high minus high low over low square. One more time, all together, make it perfect. On my count. So here's what I think. I think that on May the 5th, Cinco de Mayo, hopefully you will be in our gymnasium taking your little AP calculus exam in the morning. And you get to a little multiple choice problem that is the quotient rule, and you think to yourself, Lodi high minus high low over low squared, got it. And you get it correct. Low D high minus high D low over low square. Okay, so here we go. I have x squared minus 4x over, let's say 3x. And I'm going to use the quotient rule. Lodi high minus high low over low squared. Because right here I am dividing. This is the high. This is the low. Numerator, denominator. Okay, so let me work through this. Low, 3x. D high, what is that? Derivative of the high. Derivative of x squared minus 4x is 2x minus 4 minus high x squared minus 4x. D low, derivative of 3x is just 3 over low squared. So the 3x is squared. Lodi high minus high low over low squared.
Are you going to ask us to simplify?
No. Don't simplify unless it's like multiple choice and you look there, oh no, my answer is not there. Then you probably need to simplify. Otherwise, don't annoy your teacher when he is grading by simplifying when I tell you not to simplify.
Why don't you want us to simplify just because we'll screw it up?
That's part of it, but also like if I'm grading quickly, I don't want to work through it. And if I'm testing you over this, it will either be something that we'll work on later where you need to simplify, but otherwise, I just want to see that you know how to do the quotient rule. Okay, and so let me point, I am a dictator, but that doesn't mean I have to be rude. I'm not going to say stupid. I'm going to say careless. Okay, let me point out a couple of careless mistakes that students in the past, I'm not talking to anybody here, of course, but students in the past have made some careless mistakes. For example, do I need parentheses around the 2x minus 4? Only if you want to get it right, right? Because it's d high, it's the entire derivative of the high. If you leave off the parentheses, then it's just 3x times 2x, and then you're subtracting 4, and that's not correct. This has to be negative. Can I switch these, like the product rule?
No.
No. Can I write it the bottom like that? No. It's the entire low part that is squared. Okay? So be careful. I'm warning you. Those are the 4 rules. Any questions? I think I know what you were thinking. You're like, that's all fine and good, new house, but it really is too theoretical, and I really need some hands-on practical experience. Well, okay, let's go. Second page. Let's apply our calculus rules. Shall we? Who's with me?
Yeah.
I feel like the general has run out into no man's land, leading the charge, and nobody's with me, and I'm just going to get shot out there. Okay, here we go. Find dy dx. Dy dx means the derivative. So now here, I feel like y equals 3x squared over 4 minus 9x over 5 plus 6. I feel like students look at that and they want to do the quotient rule twice, which is fine. You can do that. But I also feel like we are card-carrying members of the Calculus Slacker Club, which means we want to do the least amount of work possible and still get the right answer. Am I wrong? Of course not. Okay, so let's simplify this. How about we say 3/4 x squared minus 9/5 x plus 6. And now I can use my shortcut. These two things are equivalent, right? I just pulled the coefficients out there in front. And I'm going to use my shortcut. So exponent is 2. 2 times 3/4 gives me 6/4, right? Yes, fractions are our friends. And then I'm going to decrease the exponent by 1. And the derivative of negative 9/5 x is just negative 9/5. And the derivative of 6 is 0. It's a constant. Okay. So on the second one, I've got like the product rule in the numerator, and then the quotient rule. It's like my two good calculus friends are getting together for a barbecue or something, right? But I want to simplify this. How could I simplify it? Foil the top. So that's going to give me x squared plus x minus 2 divided by x plus 3 Now I'm going to use my good friend number 2, the quotient rule. I'm sorry, don't look. What's the quotient rule? Low D high minus high D low over low squared. So y prime is going to be low. D high is going to be 2x plus 1 minus high x squared plus x minus 2. D low, derivative of the bottom here is derivative of x plus 3 is just 1. Over low squared. And again, leave it unsimplified for now. Okay, stop me if you do not follow what I'm doing, please. Okay. The next one, I can work 2 ways. The first way is I'm going to do the quotient rule. So dy dx is going to be low x squared, d high, and so d high, derivative of x cubed minus 5x plus 2 is 3x squared minus 10x. Minus high times the derivative of the low part, which is 2x over low squared, x squared times x squared gives me x to the 4. Okay, that's one way to do it, and that's fine. Although there is another way, which might be helpful at times, so I wanted to show you that. How could I simplify this first? Well, I could break this up and write this as x cubed over x squared minus 5x squared over x squared plus 2 over x squared. Everybody okay with that? Okay, and so let's simplify it. What's x cubed over x squared?
X.
What happens to these x squareds? Oh, now, see, first and second period had issues with algebra. I'm sure they blamed it on the pandemic, right? 6 months of being at home, quarantine, just erase algebra skills. How can I rewrite that? Awkward silence. I could move this to the top, right, and make it negative. Oh, you're like, Coach, Algebra 1 was so long ago. That's a fair point. Nonetheless, you need to know that. But I'm still not done because I haven't taken the derivative. All I've done is simplify it, but now the derivative is not hard. Derivative of x is, maybe I spoke too soon. Maybe it is too. Derivative of x, 1. Derivative of negative 5, 0. Derivative of 2x to the negative 2, negative 4x to the negative 2 minus 1, negative 3. Right? Well, our math skills are rusty. These two things are equivalent. You could simplify the first one, work it down to there, but why don't you do that in your spare time? Okay, here we go. Next one. Find dy dx at x is equal to 1. Let me rewrite this first. How do I write the square root of x? Maybe with like an exponent? X to the 1/2. And then I've got plus x to the negative 1/3. And then I'm going to pull that out, minus 6/5 x squared. Now I'm going to take the derivative and then plug in 1. Okay. So what's the derivative of x to the 1/2? Exponent times coefficient. 1/2 times 1 is 1/2. And then I need to subtract 1. 1/2 minus 1 is negative 1/2. Then I've got negative 1/3 times 1, which is negative 1/3. And then I have negative 1/3 minus 1, which is, oh, the situation is dire, right? Negative 1/3 minus 1 is negative 4/3. And then I've got negative 12/5 x. And now I got to plug in 1. So I want y prime of 1. And what is 1 raised to the anything? It's just 1. Okay, it doesn't change. So if I plug in 1 here, 1 raised to the negative 1/2 is 1. And so I have 1 times 1/2, which is 1/2. And then if I plug in 1 here, what's 1 raised to the negative 4/3? 1 raised to the anything is just 1. Okay, so that's going to give me 1 times negative 1/3, which is just negative 1/3. And then I plug in 1 here, and I get negative 12/5. And I'm going to leave it like that. Okay, if we are doing free response questions, unless you're told otherwise, when you get to arithmetic, stop. Okay, because otherwise you keep going and like you don't know how to get common denominators and you make, again, perhaps a careless mistake, something like that. Okay, so leave it.
Should we leave it as like 1/2 x to the negative 1/2? Or do you want us to multiply?
You would have to at least plug in 1 there to get full credit. So if you had 1/2 1 raised to the negative 1/2, that would get you credit. Okay, or that. But not unless you plug in 1 because they specifically asked you to evaluate it at x is equal to 1.
Oh, I didn't see that.
Okay, that makes sense. All right, well, let's look at this one. For the function f of x equals x squared minus 7x plus 5 times x cubed minus 6x squared plus 2, it says find dy dx. Okay, so here I'm going to use my good friend number 1, the product rule. Don't look. What's the product rule? The product rule. Oh, did I stump you? It's the first times the derivative of the second. Is it plus or is it minus? Are you sure?
Yes.
Okay. First times the derivative of the second plus second times derivative of the first. Okay, so I got x squared minus 7x plus 5, that's my first term, times the derivative of the second, which is 3x squared minus 12x plus x cubed minus 6x squared plus 2 That's the second term times the derivative of the first, which is
2x minus 7.
2x minus 7. Okay, u, v, v prime, v, u prime. But wait, there's more. Because what is that? What is that? What is that? Take a guess. Even better than the first derivative.
Second.
It's the second derivative. It's not my favorite. I mean, I'll tell you my favorite derivative later. But we got the second derivative.
But why is the square on the d on the top, but on the x on the bottom? Like, does that mean anything different? Or?
No, that just means second derivative. To be honest, I don't know. That's just the notation.
That's just
No, that's the
how it's
notation. That's how it's written. Mhm. Okay, so how are we going to do the second derivative? Well, we're going to take the derivative of the first derivative, which means we get to do the product rule twice. You want to do it? I'm so inspired by your enthusiasm. Or do you want me to do it? How about I do the first part? Okay, I got it. Are you sure? Are you confident?
Yeah.
All right, well, here we go. See, here's the deal, though. Let me just get on my calculus soapbox here. You can watch me do these all day because I know how to do them. And that's not quite the same as you actually doing them. So I guess that's a roundabout way of me saying that you really do need to do your homework on these because you can watch me do them. You're like, okay, got it, no problem, coach. And then I got this, and then the quiz or the test comes, and no, you don't really got it. Sorry. So what I'm saying is you need to do your math. Okay, so here we go. First term, x squared minus 7x plus 5 times the derivative of the second, which is derivative of this would be 6x minus 12 plus, now I got to do the second half of the product rule. So I got my second term, which is 3x squared minus 12x times the derivative of the first term. And the derivative of the first term is 2x minus 7. So that is the product rule for these two. But now I got to do the product rule again for these two. So I got a plus, and I'm going to do the product rule again. So I got x cubed minus 6x squared plus 2 times the derivative of 2x minus 7, which is 2 plus my second term, 2x minus 7, times the derivative of this, which is 3x squared minus 12x. I'm not going to simplify. Let's leave it. Okay. It's all good, man. Obscure pop culture reference, right? Any questions? We good? All right. We just got a couple more. How about you try? No, I don't want to do that yet. Sorry, I'll do this. This says find the horizontal tangents of the curve. Y is equal to x cubed minus 3x plus 1. Okay, so how do I find the horizontal tangents? That's a good question, Nahal. Well, thank you. I appreciate it. But take a guess. The key to calculus in the first semester, when in doubt, we are going to take the derivative, right? I mean, it's kind of like you're sitting in Sunday school class and you just say Jesus or something like that. More than likely, it's probably right. So in calculus, when in doubt, take the derivative. All right. So what's the derivative? 3x squared minus 3. That's my derivative. But now what? That's the first step, and it says to find the horizontal tangents. Are we stuck? Who shall rescue us from this calculus pit that we have fallen into? That's so boring. I would rather one of my students help me out here. Well, let's think about this. What's a horizontal tangent look like? This, right? Am I right?
Yes.
What's the slope?
0.
0. So when I take the derivative, that gives me the what? That gives me the slope. So I want to find when the derivative is equal to 0. Right? Are we out of the pit yet? I don't know. Let's solve for x now. So I got 3x squared is equal to 3. And then x squared is equal to 1. Divide by 3 on both sides. And then take the square root of both sides. So x equals plus or minus 1. Correct? So this means I have a horizontal tangent at 1 and a horizontal tangent at -1. Like if I were, let me just sketch quickly. It's a cubic function. All right, so what's at -1 and 1? It's a horizontal tangent, but on the graph, I'm going to have a what? A local max and or a local min with the horizontal tangents, okay? So let's talk about simplifying. So I think this may be a problem from a previous AP exam, all right? So this says, find the derivative of this function. It's divided, so I'm gonna use my good friend number 2, the quotient rule. Low D high minus high low over low squared. So let me do that real quick. So I got x squared plus 1 times the derivative of the high function, which is just 1 minus x plus 1 times the derivative of the low, which is 2x over x squared plus 1 squared. And so then I scan the answer choices there, and I notice that none of them look like mine. So now I'm going to simplify. Okay. So I distribute the 1 there. That gives me x squared plus 1. And then I'm going to distribute the -2x. So that's going to give me -2x squared minus 2x. And all of that is over x squared plus 1 squared. Everybody with me? And so I'm going to collect my terms. I've got x squared minus 2x squared, which is -1x squared. And then I got a -2x and a plus 1. And then that's going to be over x squared plus 1 squared. So no. No, that one looks promising. Oh yeah, they're trying to trick me into forgetting the quotient rule and squaring the denominator, but that one's it. C. Okay. So quickly now, I got 2 more. If f of x is equal to 4x to the negative 2 plus 1/4 x squared plus 4, then f prime of 2 is what? Okay, so try that real quick. Write the derivative for me first. F prime of x. And look at yours. See if it looks like mine. Negative 8x to the negative 3 plus 2/4 x or 1/2 x. And so now I want to evaluate this at 2. So I want f prime of 2. What do I do with my negative exponents? I had such high hopes that you would remember what we did like 15 minutes ago. I'm gonna put it on the bottom and make it positive. That's gonna give me an x cubed on the bottom. So when I plug in 2, I'm gonna have a 2 cubed plus 1/2 times 2. What's 2 cubed? 8. Negative 8 divided by 8 is negative 1 plus 1. Correct answer is D. All right, well, let's tie this to unit 2, what we just did, quickly. Part A, what's the limit as x goes to 2? Well, it's a piecewise function, so I need to check the left-hand side and the right-hand side. So I have the limit as x goes to 2 from the negative side, which means I'm going to plug in 2. So the top equation, that gives me 5. And the limit as x goes to 2 on the positive side, and I plug in 2, that gives me 4 plus 1, which gives me 5. Does the limit exist? Yes, so the limit as x approaches 2 of f of x is equal to 5, because the left-hand side is 5 and the right-hand side is 5. Is it continuous at 2? My little continuity test. What is f of 2? How do you know? I'm going to plug 2 in where it's defined here on the bottom. That's where it's equal. Okay, so f of 2 is 5. And the limit as x approaches 2 is also 5. Therefore, f of x is continuous at x is equal to 2 because the value of the point is 5 and the value of the limit is also 5. Therefore, it's continuous. Now, let's throw in a little new wrinkle. Is it differentiable at 2? Oh, what is differentiable? We talked about it yesterday. It means it has a derivative. And how do we check to see if it has a derivative? I'm going to check the slope on the left-hand side and the slope on the right-hand side and see if those are equal. Okay, so this one, my function is x plus 3, f of x equals x plus 3 for x less than 2, and it equals 2x plus 1 for x greater than or equal to 2. So you can look at it and tell that it's not differentiable, right? Because what's f prime of x? What's the slope of x plus 3? 1. For x less than 2. And what's the slope over here? 2. For x greater than or equal to 2. And the last thing I'm going to say, therefore, f of x, oops, not f of 2, f of x is not differentiable at x is equal to 2 because my slopes on both sides are not equal to each other. So, a couple things quickly. You have a little group quiz on Monday.